For this video, we're going to continue looking at triangles in different parts. So we're going to start off with looking at medians, then centroids, then midsegments. So for a median is a segment with endpoints being a vertex of a triangle and the midpoint of the opposite side. So a median connects vertex with a midpoint. Right? So if we look at our triangle, we have triangle ABC. So AL is a median of this triangle. We know L is a midpoint because on either side we have two tick marks, which tells me that CL is congruent to LB, so L is right in the middle. Right? So AL is one of our medians. Every triangle has three medians that are concurrent, which means they all intersect at one point. The point of concurrency of the medians of a triangle is called the centroid and is always inside the triangle. Right? So this point P right in the middle where everything intersects, that's a centroid. Your medians will always intersect at one point. The centroid theorem tells us the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So that's saying if we look back at this AL, that means AP is 2/3 of AL. So to get from A to P, we go 2/3 of the way from A to L. So if this is 2/3, that means that this part is 1/3. Right? It divides it into a ratio of 2 to 1 from the vertex to the midpoint. It's always vertex to midpoint. Right? This means we're going to have to probably use our partitioning line segment from the last unit. Right? So for example, we have triangle ABC, G is the centroid, and BF equals 9. We want to find BG and GF. So I know that this whole median is 9. All right, the whole thing is 9. I know that G is 2/3 from B to F, so it's 2/3 of 9. Well, 2/3 of 9 is 6. So if 6 is here, that means we have 3 left to get our full 9. So BG equals 6, and GF equals 3. All right, a midsegment. The midsegment is the segment with endpoints that are the midpoints of two sides of a triangle. Every triangle has 3 midsegments. So a median went from vertex to midpoint. A midsegment goes from midpoint to midpoint. Right? So this is a midpoint, this is a midpoint. Right? So DE is one of the midsegments. There's always 3, so if we said F is the midpoint of AB, then we can connect it with the midpoint of AC. And we can also connect it with the midpoint of CB. Right? So those are my 3 midsegments. The triangle midsegment theorem says a midsegment of a triangle is parallel to one side of the triangle and its length is 1/2 of the length of that side. So this arrow right here, that denotes that these two lines are parallel. Right? So DE is a midsegment and it's parallel to the opposite side. Right, so DE connects sides AC and CB, and so it's parallel to the opposite side, AB. Right? Not only is it parallel, but it's half as long. So if DE were X, that would make AB 2X. Okay, it's half as long. So for this example, we want to find X and Z. I didn't put it on here, but we know that those are our midsegments. All right, that these are the same. And these are the same. All right? So that tells me that this line right here, this midsegment, is parallel to this edge of the triangle, to this side. Right? Not only is it parallel, but it is half as long. Right? So we have 2 options. We can say 1/2 of 3Z minus 10, right? Half of this long side equals our midsegment of Z plus 8. Right? That's one equation. Or we could say that our long side of 3Z minus 10 equals twice our midsegment of Z plus 8. Okay, either way works, and we're just going to solve for Z. So first I'm going to distribute. So I get 3Z minus 10 equals 2Z plus 16. Right? I'm going to move my 2Z over to get Z, and move my 10 over to get 26, so Z equals 26. All right, to solve for X, we have the same thing. We can do 2 equations. right? One equation, we could say that x is half of this long side 5x minus 18. So I could say 1/2 times 5x minus 18 equals x. Or, I'm going to work back over this way, or I could say that twice x equals our long side of 5x minus 18. Right? Either way works. I just prefer to do twice the midsegment. So all I'm going to do is subtract my 2x over, right? So I get, or subtract my 5x over, so I get negative 3x equals negative 18. Divide by negative 3, so I get x equals 6. And that's all there is to it.